All right, so we are looking at angles of elevation and depression, and what we're doing now is we're going to be setting up triangles, but we're going to be using like scenarios. And when you talk about elevation and depression, it's setting up the scenario and giving us information about the scenario so that we can calculate or find the triangle. The biggest thing to look out for is that the angle of elevation and the depression is measured from that horizontal. So where it is, so there's the horizontal line. So you'll often hear them called, that's the horizontal line there, and the angle is moving up from the horizontal line. So angle of elevation is always done really well, but it's this angle of depression that's really, people pick the wrong angle. So it's from the horizontal line again. So that's the horizontal line. So it's from that line down to that. So you can see we've got the balloon and then we've got the boat. And so the line that joins those two objects together, that's like we say the line of sight. So it's that line and the line with the horizontal line. Okay, so often, I'm just going to show you because this is often what is incorrectly done. So if you have they often talk about there's the cliff or whatever, and then you have say a boat out at sea, whatever. So if they'll say that the angle of depression, so there's the line that joins them. So when they say the angle of depression, they are actually talking about this angle in here, like there. So that is the depression angle, okay? A lot of people put it in the wrong spot because we can often see that we can create this right angle triangle, but it's not that angle up here. That's a different angle, okay? So the depression is there. Now we can also say that the angle of depression is equal to the angle of elevation. So in this scenario, if whatever this angle is there, it's the same there. So that's a rule we can say. So when they give it to you and you're trying to set up, they might say, the boat is 200 meters from the cliff or whatever, and then they'll say what's the height of the cliff. So we're setting up a triangle that way. All right, so just be really careful with that. Okay, so we'll do a couple of questions. So the point Q on a building is visible from the point P on building A, as shown in the diagram. Building A is 16 meters taller than building B. The horizontal distance between P and Q is 23 meters, and they want to know the angle of depression of point Q from P. So when you got to find the angle of depression, so remember we're going to draw the line that connects them, and remember this is the horizontal line. So they're asking me to find this. That's my question. So you can do it a number of ways. Depends where you see the triangle, but there's also a right angle triangle if you look like that, and it's got, so if I draw that triangle out, we know that that's 16 meters, and we can see that across there's 23, so then this is also 23 meters, and in here is what they wanted me to know. So then I can use, once I've done that, I've got a right angle triangle, I've got two sides, I want to find an angle, I could use SOHCAHTOA. So I've got opposite over adjacent, so I'll say tan x equals 16 over 23. So x is going to be the inverse, or you can use NSolve if you like, that's fine. Up here, so you can do NSolve for these ones if you like, that's fine, or you can use the inverse. So we get x to be 34.8, so I'm going to say closest to A, 35. All right, so that's why we're going to do, that's elevation and depression. Let's go back and do this question here. A tree is growing near a block of land. The base of the tree is at the same level as the corners P and S. Okay, so show the correct to 2 decimal places that ST is 41.81 meters. So here we've got a triangle that's not a right angle triangle, and we've been given 2 angles, and they want me to show ST. So pretty much want me to find this and this side here, and they're giving me the answer, so I need to set it up. So if you think about what we have been doing, if we had A, B, C, we could, and this would be little a, little b, little c, because we've got 2 angles and we're trying to find a side, we're going to use the sine rule here. So and because I've got both, I need A, so I'll use the sine A part, and I have side C, so I'm going to use sine C, but I don't have this angle, but I can work this one out, because this one would be 180, because that's how many degrees there are in a triangle, minus the other 2 added together. So what does that equal? Okay, so that's 61 degrees. Beautiful. So if I pop all this in, I will have x over sine 47 equals 50 over sine 61. Okay, now because they want us to show, this is how they're getting around that you can't use the solve function. So we just want x by itself, because you want to show, because that's what ST is. So because this number down, this is timesing, if you move it over, it will if you move it over, it'll be multiplying. So I could say that x equals, and it'll be 50 times the sine 47 divided by sine 61, and you can just write that it equals what they said there. All right, so that's the way of showing. Okay, from the point S, the angle of elevation to the top of the tree. So this is why I've done this. So from point S, the angle of elevation to the tree. So what you've got to think about it is that you've got S along the ground, and then you've got the bottom of the tree along the ground as well. And they just asked you to prove that was 41.81 meters. So we'll do that. Now they said from the point S, the angle of elevation to the top of the tree. So if we had this little tree here, the angle of elevation to the top of the tree is 22 degrees. Okay, and it's asking me calculate the height of the tree, correct, answer in meters, correct to one decimal place, sorry. So if you look here, we could label it, we've got a right angle triangle, and I've got opposite and I've got adjacent. So I could use tan 22 equals h over 41.81, and you can find what you can use solve if you like and find out what that is. So I'm just going to do that on the calculator. Time. All right, so I get h to equal 16. It said 1 decimal place, so I get it to be 16.9 meters. So that's where that one was. I wasn't sure if that had a bearing question, so that's why I left it for now. Okay, sorry, I think that question, we might just talk about bearings first. Okay, so with bearings gives us a way of like pointing in directions. So if they say cardinal direction, they say north, south, east, and west. So what your main thing you need to know is that when you have your compass, and if you've got north, east, south, and west, And you've got to know, if they say, you know, someone starts, generally you have a starting point, and if they say they went directly east, you've got to know that in there is like obviously 90 degrees. So if you're between direct north and direct east is 90 degrees. So you'll see like that. So what they're most likely going to do is mainly talk about in these compass bearings. So the compass bearings will always tell you, first of all, whether you are in the north or you're in the south. So you can see here, they told me I was in the north. So I know I'm at the north. And then the next part of the bearing will tell you which way you're swinging from that. So from north, I'm going 30 degrees towards east. So you can see that would be 30 degrees in there. So if say there was a person out there, that's where they are. Okay, so if I did another one, if I said, so we've got one here, south 20 degrees. So I've started in the south and it's going towards west. So it's from the south going towards west. That makes that 20 degrees in there. Okay, so that's a compass bearing. So a compass bearing is when you have the north and the south, and then which way you're going, east or west. The true bearings is when you have so it's 3 digits. Okay, so you've got to make sure you've got 3 digits, and it's always 3 digits, and you're always starting at north, and you're obviously going around that way. So what do I mean by that? So you're at you've got your compass, and you start at north, and they're going to say how far you go round. So say if I drew a line out here, and I said that was 120 degrees true. Well, I know that this is 90, so I actually know that this little angle in there is 30 because I've gone 120 from north. All right, so just take note when they said this one's 65, you can see they put a 0. So if it's under 100, you have to put a 0 in front of it, so be careful. So they might put a T there, but generally they just got the 3 digits. It's okay as long as you've got 3 digits there. Don't worry about too much about it, whether you put a T for true. Okay, all right, so let's go do these bearing questions. Bearing questions, you must try to follow my process as much as possible because it'll make your life easier and then you won't have any troubles with these. So we're going to often draw a little compass on our points. So let's go through this question. So the road from town A runs due west for 14 kilometers. So what you do is you have a starting point. So I'm just going to start my point, and this is town A. And when you get these bearing questions, so I always it's always good to draw a faint little compass on your starting on each point really. So I'm just going to do north, and it says a town A runs due west for 14 kilometers to town B. So I go along the due west means you're right on the west axis, and you get to point B. And once you get to another point, just always good to put a little compass in so that you can see. It's mainly so you can see parallel lines and things like that. Now we're going to pop in that's 14 kilometers. Okay, it says a television mast, so it's sort of like a pole or whatever, is located due south of B at a distance of 23 kilometers. So I'm going south along the B, and because it's 23, just try to draw it a little bit bigger than the 14 kilometers, because sometimes even though you're doing a sketch, if you're a little bit off, it can deceive you. So I'm going to do that, and I'm going to do my compass so that I can understand where that is on the due south line. And I'm just going to put that's the TV, whatever that is, TV mask thing. Okay, so it says draw a diagram and calculate the distance of the mast from the town centre A. So in the end, the question is calculate this distance. So hopefully you can see you've created a right angle triangle there. And we've got two sides and we're missing another side. So because it's a right angle, I can say that I can use Pythagoras. So I'm going to use Pythagoras. So this is my H, and this might be A, and this might be B, where I say H squared equals A squared plus B squared. So I can, and then I'll pop that in. So X squared equals 14 squared plus 23 squared. And we can just use solve in that, comma X, and we can find what the distance is. So find the distance, that's what we've first done. It said to the nearest kilometre, so I just have to round to the nearest whole number. It was 26.9. So I'm going to say the distance, so calculate to the nearest kilometre. So we're going to say 27 kilometres from mast to town A. Okay, now the next thing it's asking me is here, we are asked, find the bearing of the mast from the town. So what that means, when you see these words from the center of the town, that's where you're starting your bearing from. So where the word from, this is where you're starting the bearing. So they're talking about the town center. So I'm going to start from its north line and I want to go all the way around till I hit that the line that's joining the two things that we're talking about together. So if you have a look, we know that at least from here to here, we can see that's 180. Okay, so but we still got to add in this extra bit, which I might just call in here. I still got to add that, I'll call it Y, this angle Y to so 180 plus the Y will give me the bearing, the total bearing from north. Okay, the total true bearing, I should say. Okay, so what we're going to do is we need to find out that angle. So there's a couple of ways you can do it. We can see that it's 90 degrees in there. So if we use our little triangle, so I'm going to use this triangle where I've got 14, 23, and it's a right angle. If I find out this, I'll call it Z in there, well, I know that 90 minus Z is going to equal that Y bit. So I'll go again and I'll use, I've got opposite and adjacent. So I'll use tan. So tan Z equals 23 over 14. So Z equals, so you can use solve or you can do inverse, whichever way you want to do it, that's fine.
Wait, this is a 23 over 14 or...
Yep. Is that all right? So I get Z to be, I'm going to round to the nearest degree, so 59. So therefore, 90 minus 59 equals 31 degrees, which would be, which is X. Oh, sorry, we called that Y. So therefore, we know, the bearing is equal to the 180. So that was that first part of the straight line there up to here, plus the 31. So we get it to be 111 degrees true. Or I could say, if I wanted to do a compass bearing, I could say we were where it is you could say you're at the south, oh sorry, I said it, south. So you're down here at the south and you're moving Y, which is 31 degrees towards the west. Okay, so it's up to you. Probably true bearings is the easiest one to just do, just write the full circle round how far away you are. Let's do another one. So we're going to look at this question. And so a yacht starts from point A and sails on a bearing of 0
a yacht starts from point A and sails on
now
a bearing
I've got the diagram there, but I'm going to show you
degrees for 3,000 meters
to do it.
So you can see I started that down here, and I draw.
So I'm going to say
compass.
So we've got this
point A bearings onto
and as
my
I said,
A as
always
well.
good.
So
We're going to put a compass
to do that. And then
it went they're talking about
so it went out on
and they said that it
sails on a bearing of
degrees
38 for out to another point.
So you can see here,
so
I'm popping
would be
in those pieces of data
just so I can see
found out
different points as I go along.
There.
Okay, it then changed and went on a bearing of 318.
That's where I do.
For
so it gets to a
3,300 meters.
It says once it's at that
what
point,
I've done
it alters
there
is where it's traveling.
So
we'll draw a little compass.
I've showed you in the pink.
Okay.
This is the bearing of 318.
318
from
and
the north
sail
line all the way
and
around.
after sailing,
so when I do that,
3,300
I can work
meters, it reaches
out
a
few
so
things.
318
that
would be, remember
52
that
in
this
there.
line around there
This
would be
52 down in there. That
so
was found by
318
going
somewhere out
90
here.
minus the 38,
and
because there's a right angle triangle in there, and that's how I found the 52.
Now, pop in the pieces of information
so
that you
right
know. So what they said here
with
when
this
it was
48 here,
you know, all the
I
way
found that
around
by
to
going 318.
But there's little
minus
bits that you can
270,
see.
because
If
up
it's
to the
270
west
to the
line
west
270,
line, then
and
you
that's
know
how I found
that this
that
is
48
in there.
48.
All right, so I
in there,
found
because
those
318,
and then we
minus
went up to
270
B.
and then it
48.
The question part
so
A was to find the distance between A and B. So I've redrawn the triangle
How many
over
is that?
here,
270.
and I can see that I have those two
That's
distances.
48.
I've joined a line between A and B.
Yep.
And
All right,
and then you can see
you
you can also do
degree at C is
360
100.
minus 300.
So I've used the cosine
and
rule.
that's what they've put in there is 42.
And that's
okay,
down
so
here.
they had that bit in there.
So this would have been little side
So there's
C
lots
that
of
I
pieces
want.
of information
So I've used the
that you
cosine
can find.
rule, and I've found out
Now,
the distance was
it also says
4A.
find the and that was
30.
we ended up
meters. All right,
back at
so
B.
that one's not
and so I probably
hard enough.
But then they
a little
asked us the part B was to find the bearing.
So once you do that, now it's saying find the distance AB. So we're gonna, in the end, it's always good to redraw your triangle. So we're just redrawing it in a bit more simplistic. So we're calling that B. This is A, and because we had this other corner, they're calling that C. And we knew this was 300, and this one was 3,000. And we've got to look at what we know. So what we've drawn is, we've actually drawn them up like that. So we can find this angle in here. We can see that. We know this, we've got 48 in there, but we can also find this bit, this little angle in there. And the way I'm doing that is I can see that there are parallel lines with these north lines. So I've got a parallel line, and then when I have an intersecting line, yeah, if this is 38 in here, then this bit in here is also 38. Now, I've got like 90 degrees in there, so I can see that 90 minus 38. So this bit in here is 90 minus the 38, which is going to equal 52. So I've pretty much found out that this angle, the total angle in there, is the 52 plus the 48 that I found before. So we've got, what have we got? It's 100. So I know that that angle C is 100. I'll just write it in black. Oh, you can't see that. 100 degrees. Okay, so now find the distance AB. You could use the cosine rule because AB is little c, and so off you go, and you could type that in, and I could say C equals, using the cosine rule, it'll be A squared plus B squared, which was this, minus 2, I can't fit it in, but cos 100. Okay, so that's how you'll find AB. Okay, the next bit is find the bearing of B from A. So what it means is I want to start at my A, where's A? And I want to go from its north line all the way until I hit the where it joins up. Okay, so we can see in here that red line. So there we can find that we need to find out this angle in here, which is, I'll do it another color. I'll call it Z. And Z's it's not the 38, Z's that one in between the line and here, that's Z. Okay, so you're gonna have to find that one. This one's getting a bit messy. I might pause it here. I've squashed it up a bit too much, and I think my diagram's a bit false if I'm looking at theirs. This one's a hard one because if you haven't drawn it up, I'll draw it up better and I'll do it page. So to find the bearing, so I've left my original diagram there, and you can see it's ever so, because if you try to do your best scaling diagram, because we saw before, it didn't show for me that this line was on the outside. I had mine inside the north line, so it's actually on the outside. So try to do, sometimes these can be a bit deceiving. So what they want, it wants the bearing of B from A. So when it says from A, that means I've got to start at A's north line. So you can see I've started in the highlight up here at the north line, and I go round till I hit the line that joins them together. So that would be the bearing. So I need to find out a few things. So I've sort of focused in on the scenario up here. So I can see that obviously the bearing is going to be this around to here. So I've worked out, if I find that angle A in my big triangle ABC, and then I minus that 38, it's going to give me that little green dot in there, which is going to tell me, which I can see it's that far off the north line. So this is why down here in the final answer, I'm working out that the bearing for this, the bearing must be 360 minus that green dot, because that's how far it goes all the way around. Okay, so there's a few things I've got to find. I need to find angle A. So I've gone off and used the sine rule for that, because I've got side A and I want angle A, so I'll use that. And I've got angle C, and I just found in the previous question side C, so I'll use that. So just like with our sine runs we did the other day, I popped it in with the solve, but set the function so it can only be between 0 and 180. So we need to do this with the sine rule. And we have a look at it, and we can see anyway, it's not a big angle. So it's definitely 42, but this one would not be right, because if I add 100 to that, we're already over 100, because we've got 101, we're over 180, so that one can't be a possibility anyway. So it's definitely 42, and so we've found what A is. So then I can see that that green dot would be 42 minus the 38, because we saw that little distance from the north to the line joining A and C was 38. So in the end, I find the green dot was 4 degrees, and I can then minus 360 from that. So the true bearing, sorry, you can't quite see. Sorry, if I move that up, the true bearing was 356. So this one was a little bit hard, but you definitely have got to be careful with your diagrams. All right, so two hikers, Anton and Beth, walk in different directions from the same camp. All right, so we might want to start that we've got a camp, and we'll put our compass on because they're obviously going to go in directions. We've heard that. And so here I've got my camp. It says Beth walks 12 kilometers on a bearing of 135. So I'm going to go out here because that's 135, and this would be where Beth ends up. And straight away I draw my little compass, and I'm going to add in the pieces of information that we were given. So we know that this is 135. So there's things that, you know, if that's 90, then in here, this little distance in here must be 45. Okay, so you can work out little bits and pieces, and obviously they did tell us that it was 12, so we'll pop that in there. Okay, now Anton walks from camp on a 6 degrees on a bearing of 45. So Anton's gone out 45, which is this way, and he only went for 6 kilometers. So we don't have what happened before. I should probably make my line a bit smaller because it's only 6 kilometers. Okay, and this is where Anton ends up, and I might just draw a little compass on him so I can see. Now they told me that this to there was 45 degrees. So I can see too that in there must be also 45 because it's going to make up 90 degrees. I mean, yeah, so between this north and the east line. So on what bearing should Anton walk from the lookout tower, because that's where he is, to meet Beth? So what you're doing is you've got to join the two together. So we're joining Anton and Beth, and it's Anton needs to what bearing should Anton walk from the lookout tower to meet Beth? So it's from Anton. So the question is actually, this is the bearing, that how much is that going to go there? So you can see what we've got. If I blew that up a little bit, we can see there's things that we have, information that we have. We've got that, we know that this in here is 45 as well. And because of parallel lines, so that's because I'm seeing a parallel line here with the two north lines there. So I know if to here is 45, then the opposite way is 45. So you can see if I found angle A of the triangle, so if I just redrew that triangle a little bit simpler, so we've got 6, 12, and this is what we're drawing. We've got A and B, and we called that C. Okay, if I found this angle in here, so that's pretty much angle A. If I found A and minus 45 degrees, because of, why am I minusing 45? Because in there I can see there's a little bit. So if I minus that 45, I'm going to see how far off that south line. I'm going to find out this angle in here. Okay, so it's going to equal that little angle in there. I'm giving it a little purple dot. So what I'm going to do is I'll use this triangle. Let's find out what angle A is. So I might use the sine rule again. because we do know, or actually we need another angle to find out. So let's look at C. I knew that this bit was 45 and this is 45, so it actually worked out that that's 90. So this is a right angle triangle, so we could easily find out A by just using tan in this case, because it's a right angle 90. So if I go tan A equals 12/6, and I find out what tan is, just going to do that one. So I get angle to be A to equal 63 degrees. So now I know, so 63, so A equals 63. So 63 minus the 45 would be 18. So I know that that purple dot in there, this purple dot is 18. Okay, the purple dot. So therefore the bearing is going to be, so it's not quite 180, it's 180 minus that 18. So it's going to be 162 degrees. True. And that's how we find that one. So they get a bit tough, but these I'm showing you the harder ones, okay, to help you out, and that so you've got a diagram and you've got them in your notes. So don't too many, and it's not every year, so you can maybe hope for your chances. All right, so let's have a look at this one. The diagram shows shows the route of a cross-country race, and X lies due west of the point Z. So they gave you a compass bearing, so just make sure you know. So that was north, and it's definitely on the west line. Okay, and what is the bearing of the point Y from point X? So you want to draw your compass on X, and you want from X joining to Y. So that's the question. This is what we want in there. Now, these north lines are like parallel lines, and we've got an actual, and you've got to remember too that Y would also have its so it'd have its north and that. But anyway, we want to find this. Now, because we know this is dead set, we know that's 90 degrees. So if I call that one X, and I might call this one in here, this distance Y, we could see that 90 minus Y will equal X, and that's going to be my bearing. Okay, so how do I find out Y? Well, I can see I've got 115 here and 27. So 115 plus 27. If I minus that from 180, it's going to give me this one. So if I do 180 minus 115 plus 27, we get 38. So I know this one, Y equals 38. So 90 minus the 38 equals 52. So 52 degrees equals X. So what is the bearing? The bearing of Y from X is 0.52 degrees. Okay, so there's that one. Okay, so Alaya is bushwalking, and she walks 5.4 kilometers from a starting point on a bearing of 45 degrees until she reaches a hut. So as I said, you always should put a little compass to begin with. So she starts and she goes out at 45 degrees till she gets to a hut, and we'll put a little compass in there as well. So this is the hut. This was the start. Now add in the pieces of information. Like they said, that was 45 degrees. So you also know that in here is 45 degrees, and maybe in there is 45. So pop that in. So then from the hut, she walks on a bearing of 2.8 for 2.8 kilometers on a bearing of 300. So 300 would be out here for 2.8 until she gets to a river, so we might pop it in. So we're going to add in the information. So you knew that all the way around to there was 300. So that means you can add in a few things about the bearings. So I'm just going to take that away. We know that this, if that was around to there was 300, then this is 60 in there, and we know that that is 30 in there because we've got the west line there. So you've worked out, and then it says she returns from, she was up there at the river, and she returns and walks back to the starting point, and it says the total distance. So we're probably going to know, we know if we look at, just simplify our triangle out here, we know this was 5.8 and 5.4, and we know that this was 2.8, and we've actually found this angle in here. If you add those two together, we've got that 75, and we need to find out this distance here. So this is where I'm going to use, if I labeled it out, I could use the cosine rule. So the cosine rule would be x equals the square root of the two sides squared, you add them together, minus 2 times those sides times cos the angle in between, which was 75. So if we do that, we get 5.4. Okay, so then if you add all those together, you get 5.4 plus 5.4 plus 2.8, so you get 13.6. So we get that in total if we add them all. So that was 5.4 plus 5.4 plus 2.8. Okay, this next one, the course of a yacht race is in a triangular shape and marked out by the buoys, the T, U, and V. The starting buoy T sails on a bearing of 30. So they probably not like extending it up as much as we might like to do. So we've got that. So it goes at 30 to buoy U. From the buoy U, the yacht sails to buoy V and then to buoy T. The angle of UTV is 69, so they gave you that, and they gave you the angle of the other one, 47. The bearing of the buoy U, now they're saying from buoy V. So that means you start at buoy V's north line, and you're going to go from that north line all the way to the line that joins U. Okay? So you have a few things in here. So you can see that we, down to this line, down to this bit would be 180. So really what I need, and I've got this bit's 47, so I probably need this line in here, this angle in there. Now, if we have a look, they told us we've got, this is like a north line coming up here, two north lines, and then you've got the line that's joining T and V. So we actually can see that this angle from there to there would be the 69 plus the 30. So this would actually be 99. Now, if that's 99, then this bit from here to here is 99, because we know parallel lines, if you have parallel lines and a line intersecting, if that angle is 99, then this angle is 99. Okay, so we can work out the bearing is therefore 180 plus that 99 plus the 47. So we've got to add, we know this is bits 99, but we have to add the 47 as well, so we can get that full loop around. So we get
47 plus 99 plus 180. So we get 326, which is that one. Okay, Melissa flies 75 kilometers on a bearing of 204. So let's start her off. So this is the start. And I'm going to pop in my compass. And she flies 204. So that would be at here for 50 kilometers. So I've got that's 50 kilometers. And I'm going to pop in a compass bearing on where she is. So we saw that was 204. So really what we're saying from here around to here was 204. So we can find out other things. We know to the straight line is 180. So in here must be 24 degrees from here to here. If you know that is 24 degrees, you also know that that's 24 degrees. Just handy to pop these things in. Probably going to come in handy. Alright, when she gets to this second point, she goes on a bearing of 150. Oh, sorry, this first distance was 75. Sorry, am I wrong? And then so she goes then on a bearing of for 50 kilometers on 150. So I'm going to say that's out here for 50 kilometers. And she gets to her next point. Okay, so let's pop in what we were told there. We were told from here to here was 150. Okay, so that was 150. So what else can we see? We know in here is 90. So then that makes this one in here 60 degrees. Okay, and then also if we know we have 90. Okay, so we see that in here, because it's adding up to 90, a right angle, this must be 66, because 90 minus 24 is 66 degrees. So back to the question. The question's asking us find the distance from the starting point. So if we join these two up here, that's what we want. So let's go simplify our triangle a little bit, because we've got a lot of information and we just want to get it to be a bit more simpler. So I know that this is 50, this is 75, and I now can see this angle in here. If I add 66 and 60, I get 126 degrees. And obviously X is the question. So if I label this triangle up like my A, B, C, it'd be little c that we want. And if we went through our flow chart, it says, do we have a right angle triangle? No. Do we have more than one angle? No. So we'd be using the cosine rule. So the cosine rule for if we're trying to find little a, will be the square root of b squared plus c squared minus 2bc cos a. So if we substitute that information in, b is 50 plus 75 squared minus 2 times 50 times 75 times cos 126, and we get approximately 112. So C. Okay, so triangulation is the method of triangles used to solve some theory problems. So often we see if you're a surveyor and that, they might have where they want to measure this distance across, say across a lake like that. As you can see, there's a lake there. So they can't physically walk through the lake to get from, measuring with a measuring tape or whatever. And so what they do is you'll often see those surveyors. So they take 2 points. So here they've marked on A and C, and they've put those sticks up with the radars, and then they've got a point on the other side of the lake. And then they link it up and they find these angles of degrees between the straight lines between them, and then they can calculate distances, because they can get here and they can get here and they can get here outside of the lake, but if they want a direct distance. So say here the question was to find AB, the direct path. So AB, if we use their little triangle, would be little c. And we've been given little b, So we probably are going to have to use, we know we have to use sine C in our thing, because if we went through our flow chart, do we have a right angle triangle? No. Do we have more than one angle? Yes, we're using the sine rule. Now I've been given B, so I'm probably going to be using that too. But if you look, I don't have B's angle, but that one can be found out because we know this is 55, this is 65. This one would have to be 180 minus those two added together. So we end up with this is 60, and that's how they get that. And then we can just plug in all our information that we know, which would be there, equals B 100 over sine 60. Okay, and then we can just use solve on our calculator. So we're used to just doing solve, comma C, and we'll end up with their answer that they got there. Okay, so here's an example of triangulation. So we've got Marcus opposite the lake and from a horse and a stable, and the stable is 150 meters directly east. So we probably want to pop in a bit of our compass so we can see what's happening. So they're saying it's directly east along here, and we've got 150. Okay, now Marcus is on a bearing of 170 from the horse. So that means we start at the north of the horse, the north line on the horse, and we join it to the line joining Marcus and the horse. So they're saying that's 170 degrees. So we can see a few things. We know that's 90, so it makes in here must be 80 degrees. So we know that. And then the next bit of information, it says Marcus is on a bearing of 205 from the stable. So you go to stables north, and it'd be all the way around there. That's 205. Now we've got to remember that directly down round to the west line is 270. So we can find out that this in here must be 65 because 270 minus the 205 is 65. All right, so the question, the straight line distance between Marcus and the horse, that's here. So let's draw our triangle out with a lot less mess and see what we've got. So we've got 80, we've got 65, got 150, and we've got X. All right, so if we go through our flow chart, do we have a right angle? No. Do we have more than one angle? Yes. So we're using the sine rule. So if I just label up the sine rule, I have to use C because that's the question. This is little c, this is little a, and this is little b. So I'm going to have to use the C in my combination. And I'm going to use A because they gave me side A. Okay, we need to find this angle. So that is going to be 180 minus these two, which is going to be 35 degrees. So then we can plot in everything we know. So sine 65 equals 150 over sine 35, and we're just going to pop in solve, comma C, and we get C equals 237. Okay. This question 10 I've done on a separate video. It's from the 2020 exam and a big one, so that's a separate video.